Hi, everyone. We're looking at the next chapter. I'm going to consider this part of the same unit because there's a lot of overlap between the exponential unit and our section and this section. So chapters 4 and 5, at least, will be grouped together as a unit test, so you're aware. And so we're looking at chapter 5, which is about saving and investing money, which ends up being applications of linear and exponential growth. So we're going to look at simple interest first. And so starting out, let's just talk about what interest is in general. Interest in general kind of talks about it right here, where when you deposit money in a bank account, you're basically lending money to the bank, and then they lend it to other people and make money with it, right? So they lend it out and make money off of it. Good enough. And so basically they pay you for that, right? So they pay you interest. They pay you some money for the use of your money. So with simple interest, and you could think of simple interest as not very realistic. And I say that because there's definitely some examples in the homework questions and textbooks typically that aren't very realistic. So they have an investment plan that's earning simple interest, which doesn't really exist. If you go to a bank and ask for a simple interest investment plan, they're gonna be like, sure, sign you up, because you'll see why it would be silly to do. Okay, it doesn't really exist. So simple interest exists in the context of this application or this example we're going to look at. Another common one, though, would be like if you're getting a loan from grandma to buy a car or something like that. Grandma might just say, "Oh, I'll charge you $300 a year interest all the time. It's $300 every year." That'd be a simple interest kind of case too. So the way it's described here is sort of the realistic version, though, where interest earned each year is taken out. So it's not added back onto the original amount. And so then the key is that the interest is calculated on the same amount or same value every year. That's what makes it simple interest. Okay. And that's not super common because typically the interest adds into the total and you end up with interest on interest, and which means the amount of interest you get gets more and more, but we'll see that in the next lesson. Okay. So this example here, we have Rachel was born, her grandparents deposited $1,000 into an account that earns 6% per year for 5 years. So there's basically each year they're taking out the money. Okay, so every year on her birthday, Rachel receives a check for the interest earned. So that means that the amount invested, okay, so basically, it's always $1,000 in the account. Assuming the grandparents go to the bank on the last day of the month and take out the interest and don't let it ever earn interest on the larger amount. Okay, so the account. So interest is always, you can see how that makes this be simple interest, right? And we're just going to use this example to learn about how money grows in that kind of scenario. So some of the things are going to be familiar, hopefully, when you do 6% of 1,000. Percent means divide by 100. So we just convert it to the decimal version of it. So it's 0.06 times 1,000. That's the interest earned. So that's each year, right? So total interest earned there so far would have been $60 from doing that. And then the total amount of money, including that $1,000, would be the 1,000 plus the 60, which would give you, of course, 1,060. Right? Keeping going here, we've got $1,000 in the account again because we took that money out, right? So remember the birthday gift here. So take away 60 for the birthday. And that leads to, take away the 60 for the birthday, leads to $1,000 in the account, which if you go back to the beginning here, starts us over again, that process. So we're just going to do that a bunch of times. So every single time here is going to be 0.06 times 1,000, giving you $60 interest earned. Okay, so we'll just fill all these in. Giving us $60 each time. Okay, so that's going to give us then, you can just tell, let's look at the numbers here. We'd have 1,120, we'd have 1,180, we'd have 1,240, and we'd have 1,300. Okay, so what we're going to do is we're going to look at the interest equation and like how the interest adds up. Yeah, total interest. Sorry, this one here is not supposed to be. It's supposed to be total interest earned. So that's supposed to go to 120. In order to help me make the equations, I need to have that. Okay, so the 1,800, the 240, and the 300. All right. So the interest equation. When you look at what happens here, if we were to go out to any number of years n, what would that be? Well, you've got this one. Let's go interest equation. We'll analyze in sort of purple here. Okay, so we have the 60, and then this one is the 60 times 2 gave this. Then this would be 60 times 3 giving this, and 60 times 4 giving this, and 60 times 5. Right? So really you can tell it's just 60 times the number of years, right? So the interest equation is basically just the interest. Now the 60 comes from the actual rate, right? This is the 0.06. Times 1,000. Which if you think about it, that's your rate times your time, right? So I'm going to put this as interest rate times the money, sorry, not time. So really the interest equation is your interest rate times the amount of money. That's your interest, how much money you have. And then it was times the number of years. I think we can see that equation would make sense, because like the rate times the amount of money you've invested times how long it's been invested for, basically, right? Your total equation, pretty obvious what we did here is we'd always just have the 1,000 plus the extra. 1,000 plus the extra all the way along. Right, so if you look at the total money equation, right, so the total money equation, so this one here, before that was total interest. So let's do, just do I for total amount of interest. That's what it's going to be on the next page. And then here, we're going to do total amount of money. And so it's A for amount. So it's going to be A. And you can tell that the A is just equal to, the amount is equal to the original amount of money. So let's do money invested, whatever, plus the interest, right? That's just the concept that makes sense from what we saw. So we'll stitch this together shortly here and do an equation on a future slide. But for now, we basically have the equation. We're just going to assign variables to it, and it'll be exactly like those. I'll bounce back to it and show you. They're the same. So just to review a little bit of the stuff we've done, why is the interest the same each year? Well, that's because there's always the same amount of money. So interest same each year since the amount of money invested is the same, right? So there is always the same amount of money. That interest is growing on. There's always a certain interest rate of the exact same amount of money. How does the total amount of money, total interest accumulate after 5 years compared after 1? Well, after 1 was 60, and then it was like times 5 gave the 300, right? So, how could you get this? Well, it'd be like the interest per year, right, times the number of years. Very obvious stuff and what we've looked at, right? So the part that we're going to make a connection back to the previous unit, we just saw a lesson recently about types of relationships and so on. If we graph this situation, we have the amount of interest after 1 year was 60, and then after 2 years was 120, and then after 3 years was 180, for 4 years was 240, and after 5 years was 300. So if we had the graph going all the way up to 300, it'd be there. And so looking at this graph, obviously we can tell that it's a very straight line, so it's a linear relationship. Okay, so it's clearly linear. And then if we went back and thought about the table, so on the graph, it's obviously linear. If we went and looked at the table of numbers, our table had numbers in it. Sorry about that. So the table had what? I'm just going to go, I meant to hit the eraser, but I hit the screen there. It's supposed to be blue. Be blue. All right, so we had basically the numbers in here, the interest was growing, right? So the interest was 60, and then 120, and then 180, and then 240, and so on. So in the table, we had this add of 60 all the time, right? And so we have a constant first difference, which of course verifies that it's linear as well. So in both cases, both ways of analyzing, you can see that it's a linear situation. Okay. All right. So that's just this type where you have simple interest. And then when we go to other types of interest, we'll make other connections as well. All right. So to go back to that equation, I should have just done it on the other page, I guess, but it was a handout all on one page. So here we go. So the summary of this, we had an equation that's basically that, right? Where we had I as the simple interest and P is the principal. That's the word they're using for the amount of money that's invested. So this is just money invested. They want to use, they're trying to avoid using the word amount. They save the word amount for the amount of money that, like the principal and the interest, the invested money. So invested money is your principal plus the interest, right? That's what your amount is. They use a very specific word for that, so they're not using the word amount over and over again. But unfortunately, in the English language, we tend to use the word amount for money that's been put somewhere, right? The amount of money. Anyway, so principal, P is your principal. It's the amount of money invested. There you go, saying an amount again. R is your annual or yearly, in other words, interest rate as a decimal. So to get as a decimal, of course, you know that percent means divide by 100. And your T in the equation is your time in years, right? So we end up with just with A equals P, A equals P plus I, and I equals PRT, principal times rate times time. So that's the equation to do with this. So then we can just analyze this and work out the answers here easily enough, right? So good idea to sort of look at what you're given. So that's obviously your principal. This is your time, your number of years, and then this is your rate, or almost your rate anyways, as long as we do this as divide by 100. So that means we've got a P equals a 500, T equals 3, and a rate equals 2.25%, which means 2.25 divided by 100, which means 0.0225. So it wants the amount of the investment. So what I'm going to do first is I'm going to get the interest. So I equals PRT. So we have a 500 times the rate times the time. So that gives you whatever it gives you, right? So 500 times 0.0225 times 3, 33.75. So 33.75 in interest. And then second is the amount, which we know is equal to the principal plus the interest. Don't even have to think of it as an equation really, but P plus I, of course. So the principal was, in this case, $500. And then the interest was the $33.75, which adds up to $533.75. Right? And it's one of those kind of questions where a therefore statement would make sense to write in the end. Therefore, the amount of money, amount of the investment, the value of the investment would be another way of saying it in a little more real life context. But in a math context, they say the amount of the investment is $533.75. It's the value of it, what it grew to. Okay. Yeah, so there's that. One twist to be aware of is that sometimes you might start an investment and then you end up taking the money out partway through the year. Banks have to be able to calculate how much money to give you if you're partway through the year. And so your time given divided by your full year gives you your fraction of a year. And so it gives you really the fraction of the amount of money you should get, right? So the fraction of a year is obviously the same as the fraction of the money that you should get, right? So in the same time units, right? So if instead of investing for a certain number of years, you invested for a certain number of days, well, you'd have to divide by the number of days in a year. You get 365. So for example, if you invested for 60 days, then you divide by 365, and that would equal some fraction of a year, right? Some fraction of a year. If it was half a year, it'd be half of 360. Your number of days would have been half of 365, and you'd get 0.5 as your fraction. You can take it out after a certain number of weeks, in which case you'd have to divide by 52, number of weeks in a year. So if you invested for, let's say if you invested for 26 weeks, after 26 weeks, you pulled out the money, that would be half of a year, fraction of a year. And if you invested for months, then you'd have to divide by 12. So you'd have, say, 4 months divided by 12 would give you 1/3 of a year, right? Because you could divide both by 4. It would give you 1/3 of a year. Which should make sense, right? 0.33 would be your fraction of a year. So that would just be what goes in as your t value. Okay, so each one of these would have been your t. It would have been t equals that for 60 months, t equals this for 26 weeks, and t equals 0.33 for 4 months. Sorry. So same idea here in this one that's ready to go and worked out here. $10,000 for 5 months in an account that earns 3.4% interest per year. So they're asking what amount of money you'll have or what the value of that investment is after 5 months. So in other words, it says after the investment matures, or basically when Peter cashes out, gets the money. So just like I did before, we have variables. So we notice that the P is the 10,000, the R is the 0.034, and the T is 5/12 because this is your fraction of a year, right? So right away, even in here, you might have said, okay, well, I'm obviously going to do T equals 5/12, right? Make that look more like a T instead of a weird E. This, you would have said, okay, well, that's my principal. It's the amount of money I've invested. And here, you would have said, okay, R equals 3.4% or 0.034. Don't forget to convert to decimals, right? You need the decimal equivalent. Otherwise, you're multiplying everything by 100%, like 340%. The equation was I equals, I don't like that they didn't put the equation in here, B times R times T. Right, it's always good to start with the equation and then put values in. So if you put the values in, we'd have 10,000 times 0.034 times 5 over 12. You would just do the calculation, like 10,000 times, what was it again? 0.034, then times 5 divided by 12. You literally just do all of the things it says to do. It spits out 141,6666 or 141,67. Banks actually carry 6 decimal places and then round to 2 to give you your money. Okay, so there's a typical therefore statement. Interest earned is 141.67. The amount would be the original invested money, 10,000, plus that interest. So it would give you this number here, 10,141.67 cents. All right, so that is it for this lesson. Covered a little bit of stuff there for sure. The idea of like simple interest and the idea of it, what it is, and that it's really a linear relationship and so on. So here's some practice questions that will get you to reinforce that skill or those new things we've learned. All right, if you have any questions, let me know. Otherwise, thanks for watching. Till next time.